All right, boys and girls, today we're going to solve by factoring. So we're going to be doing or factoring and graphing, I should say. First thing is that I already have the graph or a rough sketch of what the graph looks like of x squared minus 2x minus 3. Hopefully you remember from the previous day that concavity is whether it's up like a cup or down like a frown. This one is up like a cup. The axis of symmetry is the invisible line that goes through the vertex. And that's always x equals, and then what's the x value? In this case, it is positive 1, the x value right there. The next thing is my vertex. So where's my lowest point? That is 1, comma, negative 4. The lowest point, that's my vertex. It's also called a minimum. The next thing, the y-intercept, is where it crosses the y-axis. So that is 0, comma 3. Last thing on this review is that the domain is all real numbers because the arrows go always forever to the left, always forever to the right. Last thing, my range, everything bigger than, we start at the bottom, so everything bigger than negative 4. Now, one thing I did not talk about is this thing that says factor right here, and that means we're going to factor this. So if I write x minus 3 and x plus 1, that's going to give me the same thing. And that's what this first question asks. What is the difference, or is there a difference? If we graph this in our y1, we graph this in our y2, they're going to be the same. So there is absolutely no difference if I graph the factored form or if I graph this form, the standard form, is going to give me the same equation. All right. As we were saying, they're the same exact thing. Now the new stuff today. The new stuff is we're going to list any other names for the x-intercept. Now x-intercept is where they cross the x-axis. So on this, those two things are the x-intercepts. There's like 3 other names for x-intercept. One is called the roots. It's where the x-axis is, where they cross. It's all the same stuff. Another one is the solutions. And the last one is the, what am I thinking here? Oh, zeros.
We went over this last year.
We did. All right, so number 1 wants to know how any of those words can apply. So you can either put x-intercept in the blank, you can put roots in the blank, solutions or zeros. I want to put zeros because I want to. So it wants to know for A, B, and C how many times the graph crosses the x-axis. So this is 1. Yep, B is 2, and then C is 0. Not too difficult there. The next part is all calculators. So whip out those TI-83s or 84s or whatever you got, and we're going to go ahead and put y1, x squared plus 7x plus 10. So I'll show you what I'm doing in my calculator up here.
7x plus 10.
X squared plus 7x plus 10. Then it says in our y2, we're going to put 0. So be sure that our y2 is 0. From there, it says, or wants to know why we're doing this, is because we're going to find the intersection. Find intersection. So when that didn't even look like intersection. Find the intersection. So when I go back to this graph right here on the big screen, it looks like it crosses 2 times. I want to actually figure out what those 2 points are. So once again, we need to be sure that we have y1 there and our y2 is 0. Yours probably won't have 2 colors unless you got a fancy color calculator. You can probably barely even see the y2 being equal to 0. You probably won't. How many times does it cross the x-axis? It crosses 1 and 2. So that means my first answer right there is 2. Then I'm going to let the calculator do all my work for me. So go ahead and watch up here, and then you can do the next one. I'm going to first, this is written on your notes, so I'm going to press second, trace, and then I want to go down to number 5 and press the intercept because I have 2 different lines on there. I got x squared plus 7x plus 10. On my y2, I got 0, so I'm finding the intersect. I press enter. First curve, yes, my parabola is my first curve. Second curve, my cursor should jump down. So then I'm going to press enter again, and I'm going to go over, arrow over to where my intersection is. Press enter one more time, and it's going to give me -2, 0. Alrighty. So if you weren't watching, let's do it one more time. We'll press second trace. Go down to number 5. First curve, yes, enter. Second curve, yes. And then let's go over to the left this time. Let's find our other 0. So I'll find my other 0 by pressing enter. My intersection is -5, 0. So my two zeros are -2, or my two roots, or my two x-intercepts, or solutions, -2 and -5. So on number 3, it works the same way. Plug into the calculator. So we go into our y1. Be sure your y2 stays there. And be sure you use a negative sign instead of a minus sign. I'm going to do x minus 2 squared. Be sure I write it down right. Yep. And then plus 1. Once again, press graph. It's up or it's down like a frown because of the -a. And you can actually see where they intersect. You don't need to do second trace. But if you wanted to, you can still do the same process, second trace, blah, blah, blah. Either way, we're still going to get 1 and we're going to get 3. So I'll go back here, and how many solutions are there? There are 2 because it crosses 2 times, 1 and 2. And then lastly, we already said there are 1 and 3. All right. The next part on your notes is something you'll need to copy down. So go ahead and pause it right here and copy this down. All right, so step 1 is we're just going to set the equation equal to 0. So 3x squared plus 3x minus 6 equal to 0. That's it. The next step, struggling talking. The next step is that we're going to factor completely. So the first thing, we're going to take the GCF out. So all this can have a 3 taken out. So x squared plus x minus 2 equals 0. The next step, which is still part of step 2, is we have to factor this. So then we do our 2 sets of parentheses, what times what makes -2, and adds it to +1. And that's +2 and -1. That's factoring stuff. Go back and watch my factoring video if you're struggling with that. The next thing is step 3, we're going to set each part equal to 0. So 3 equals 0, comma, x plus 2 equals 0, comma, x minus 1 equals 0. The last step is we're going to solve each of them. So does 3 equal 0? Absolutely not. So I'm going to cross that out because 3 does not equal 0. It cannot be a solution. The next one, I'm going to solve this. So move 2 over. And so one of my solutions is -2. My other one, move 1 over. So my other solution is x equals 1. And that's it. Now, you may ask yourself, why are we doing this, not using the calculator? Well, some might argue that this way is a heck of a lot faster than doing the calculator because I don't have to do the second trace stuff. I can see it there. I can get exact values. I don't have to use anything, blah, blah, blah. So if you're more comfortable doing it by hand, do it by hand. More comfortable with the calculator, do it with the calculator. Either way. Let's try this one. First step, we got to do something first. We got to get everything on one side. So I want to move this junk over there because it's not equal to 0. So I still have 2x squared. I move 5x over, so it becomes positive 5x. I move 5 over, so it becomes -3. And that equals 0. Next step, I do GCF. I don't have any GCF. So I got to do a little trickery here. Normally I would tell you to do AC method, but I'm going to show you a little shortcut because it's a shortcut. There are only 2 factors of 2 and 1. So I know one of them's got to be 2x, the other one's got to be an x. There's also only 2 factors of 3, 1 and 3. The last thing you got to figure out is where do 1 and 3 go and which one has a plus and which one has a minus, because a positive times a negative is a negative. So I'm going to play this guess and check game. If I put a negative sign here and a positive sign here, I still get 2x times x is 2x squared. I still get -1 times +3 is -3. The last thing is 2x times 3 is 6x. The inside stuff, -1 times x is -x. Does that add up to my middle term? Sure does. So I did everything right. That's a short little cut there, or shortcut I should say, that'll save us a little bit of time factoring stuff. You can use it if you would like. If not, you can do the AC method where you multiply 2 times -3 and do all that stuff. So it works the same way. The third step is to set each part equal to 0. So 2x minus 1 equals 0. And x plus 3 equals 0. The last step, solve for x. 2x equals 1. Divide by 2. So x is 0.5 or 1/2. And x is -3. So those are my two answers there. Once again, you can do the calculator if you want. This is how you do it by hand. I got two more problems, and they'll go pretty quick. Let's see if I can get it all on one page. Nah, can't really. Number 6, go ahead and pause it, read it. It's kind of challenging. It says the shortest leg of a right triangle is 7 shorter than the other leg. So if I call this one x, oops, sorry. If this one is x, this one's going to be x plus 7 because this one is 7 shorter than this side. And it says it's 8 shorter than the hypotenuse, so that would mean this one is x plus 8. Then I'm going to use the Pythagorean theorem, which we all know by heart. A squared plus b squared equals c squared. So I have x squared plus x plus 7 squared equals x plus 8 squared. So from there, go ahead and square everything. I'll save you some work. This, if you FOIL or box method, is going to be x squared plus 14x plus 49. Pretty please do not just square both of them. You'll miss out on the 14x. Then I get x squared over here. Same thing, box method or FOIL. Sorry about that. Plus 16x. What the heck? Tripping out. Plus 64. That's weird. Sorry. Next thing we're going to do is we're going to move all this on one side. So x squared and that x squared go away. Oh, sorry, I'm missing an x. 16x and x and 14x to make negative 2x. Move 64 over here and I get negative 15. That equals 0. Once again, we're factoring, so what times what makes negative 15 and adds up to negative 2? Just think about it. You're going to get negative 5 and positive 3. Then you set each part equal to 0. You get x is 5 and x is negative 3. Now we're dealing with a real-life situation, as much as triangles are real life. We cannot have a negative side of a triangle. That doesn't make any sense. So negative 3 is out. 5 is our only answer. So that means my three sides are 5, 13, and 12, which that's a Pythagorean triple if you're familiar with those, or if you're not, whatever, 5, 12, 13. The last problem is something that we kind of got to use our brains a little bit on in looking at our table here. We don't want to graph this in the calculator. We're estimating. So I want to know the solutions. Well, if you think about solutions, the y value is positive and then it gets negative. And then it's negative and then it gets positive. So I want to look at our y values and see when did it go from positive to negative. Well, right here, went from positive to negative. So that means I have a root somewhere between negative 5 and 4.5. Halfway between there would be negative 4.75. Just halfway between there. Then it stays negative, it's negative, still negative, still negative. Then it goes to positive. So that means it changed again between these two values. So negative 3.5 is my other one. Last thing, I'm going to clean my table up, is where is my vertex? So remember, vertex is between the two lowest points. So I look to see where my two values are the same. Two values the same are right here. So which x values are they between? They're between negative 4.25 and negative 4. That's all I got. Good luck. Let me know if you got any questions. See you in tutoring. Bye-bye.